Hi guys, welcome to the session and let me explain the layer 2 protocol that is known as the spanning tree protocol step by step. And it's a very important if you are bring your journey in the switching environment and you want to learn switching from the scratch, you should always be champion of the STP, that is the spanning tree protocol. So why we use the spanning tree protocol and what is the importance of that spanning tree protocol in layer 2 network, that we have to understand. So basically this protocol is known as to avoid the loop in the layer 2 infrastructure. So how it is going to avoid the loop? Let's suppose taking a very simple examples. In my networking, we have two switches. This is one switch, switch 1, and this is going to connect to another switch, switch 2. They have two links. Take an example, and one PC is connected here and one PC is connected here. So what is going to happen when the PC is going to send the data, might be it is going to this link and again going to return back to this link. So it is going to form the loop, means you're sending via the link, again you're going to come back the same process and it's going to be again. It's keep looping the packet on the layer 2 infrastructure. So to avoid this situation, means when I'm sending the packet from one switch to another switch, it should not return back to me again and it's not going to form a loop. We use the STP, that is known as the spanning tree protocol. This protocol is going to make sure there is no loop going to be happen in the layer 2 network, and that's why this protocol is very important. And most of the network engineer always fail to understand the key concept of the STP, how STP work and what is the key principle of the STP and what is the right approach to understand the STP. So I will try to bring those gaps and you're going to understand step by step all the STP concept in this lecture. So stay tuned with me and let's understand one by one. So let me move to the different slide. So you can see what is STP. So STP is basically it's a IEEE standard. So IEEE standard is the global standard which designed by the IEEE, which is going to make sure every vendor have to follow this standard when they design the switch for the any network infrastructure. And these standards are going to make sure the loop prevention is going to happen if you're running this protocol. So it's going to create a tree-like topology, and that topology is going to be completely loop-free, and that going to block the redundant link but keep them as a backup. What does means? Means when I'm going to block the any link, let's suppose this is my switch. Switch 1 is connected with the switch 2. So there is a one link, then there is no possibility to make a loop. But if I have the two link, then there is a possibility there is a packet is going to be there and is going to be come there and going to make a loop. So if I want to prevent that situation, so I will connect the two link again, but one link is going to in the block stage. This is going to be in block stage. So all traffic will going to forward from this link only to this PC to this PC. This is going to be only happen. But in case of this link is going to failure for any region, it is going to use this link to transfer the data. Means this link is going to act as a redundant link. Means the mention is a block redundant link, but keep them as a backup. Whenever needed is going to be happen, it is going to activate for redundancy purpose. So this IEEE 802 dot is a technology that is represent to the STP. That is a legacy and old protocol. There are the multiple versions of the STP. There is RSTP, there is a MSTP, there is a PBST. I will discuss one by one all the protocol, but very first protocol that is known as the STP, that is the IEEE. Okay, so now moving forward guys, and after moving forward, the goal is going to be happen one active path between the switches. Means if you have the multiple link, only one link is going to save the data. So avoid the link, means zero loop is going to be happen. And in case of the multiple link available, one link is fail who is just exchanging the data, the automatic backup link is going to be available to make sure my data transmission is not going to be impacted. So I hope you understand that. So let's understand why do we need STP to just create this loop-free technology. So you can see this topology. What is going to happen? Let's suppose there is a one switch. Take an example. This PC want to talk to this PC. This PC want to talk to this PC. So what is going to happen? There is a path I can talk to this way. But this packet again going to come back to me. If I'm going to this path again might be going to come back to me. It's going to the PC. So it is going to create a loop. And if the loop is going to create it, your CPU processor means processor of CPU is going to be increased and your switch might be going to be dead and your network is going to be down. So basically switch forward the broadcast in on unknown unicast frame in case of the any kind of the layer 2 connectivity. Broadcast a storm that is going to create the MAC instability and multiple frame copy is going to be generated. Due to that your loop is going to be created and finally your entire topology is going to break. So to prevent that situations, we use the STP, which is going to make sure there is no loop is going to happen in network. Now, so whenever you're going to design any kind of the STP protocol, the key component is going to required. How the loop is going to be prevented and what are the key component is going to needed. The very first thing in the STP we require, that is known as the root bridge. This is my root bridge, right? Again, we have the bridge ID, we have the port roles, we have the port state, and we have the BPDO. So if you want to understand the STP in depth, you just have to understand what is the root bridge and why we need the root bridge, what is the bridge ID, why we need the bridge ID, and what is the port roles, and why we need the port and what is the port state, and most important, what is the BPDO. So let's understand one by one. Bridge ID. Every switch have their bridge ID. Bridge ID is basically, by default, when you're going to enable the STP, by default you are going to find STP is enabled on the switches. I will show you in the lab infrastructure how you can check the switch having the STP enabled or not. But by default, you are going to find either RSTP is going to be enabled or PBSTP is going to be enabled on the latest switches. Some legacy switches you are going to find STP is enabled, but right now this STP you rarely find to enable in the any switches. But if you want to run this STP, you can do that. But either you are running the RSTP, I will discuss what is the RSTP, or STP or PBST, you always require this bridge ID. And what is the bridge ID? Bridge ID is basically combination of two parameters. The first, every switch having their priority. And what is the default priority? 32768. So this priority is always going to be there on the every switches. Whenever you're going to purchase a new switch, this priority is default available on the every switches. And the second thing is switch having their MAC address, right? Means MAC address means every port which is connected, they have the MAC address from where the link is connected. So you are going to get the two parameter. One is the priority and one is the MAC address. Based on these two parameter, your bridge ID is going to be calculated. If your switch having the lower bridge ID, let's suppose this switch having the bridge ID 32760 and this having a 768 and this also having 768. So this will become by default like bridge ID is equal to your priority plus MAC address. So this is going to be there. But if you have the default, then it is going to be default bridge ID like whatever the priority is going to be there. But if you want to select the root bridge is going to be selected based on this particular your bridge ID. Means whatever the bridge ID is going to be lower. Bridge ID means either your priority is lower or your MAC is lower. Means there is two combination is going to happen. So root bridge selection is going to happen. Let's suppose this is my switch. In this, who is going to be my root bridge or root switch? Who is going to my root switch? So root switch is basically going to depend on the priority plus MAC address. Means this value is going to be lower. Let's suppose priority by default is lower. So there is no significant role of the MAC address. Means let's suppose this switch having a priority is, let's suppose I'll make the priority is like 100. This is going to be 200. This is going to be 300. So by default, this is going to become my root bridge. This is known as the root switch. But if all priority is going to be same, if all switch have the same priority like 32768, 32768, 32768, so who is going to become my root switch? In that case, your MAC address is going to be tiebreaker. The switch which having a lower MAC address, that is going to become my root bridge or root switch. So this is why bridge priority is going to be always, bridge ID is always going to be exchanged between the switches. It helps to calculate the my root bridge. And the root bridge have the significant role. Without root bridge, you cannot establish any STP or RSTP topology. I will discuss more about the root bridge, but you can just understand. Now default priority 3276, lower bridge ID is going to be there, right? And MAC address user tiebreaker means if the bridge ID is going to be same, means the priority is going to be same. If the lower MAC address is going to be there, that is going to be tiebreaker. The switch with the lowest bridge ID become the root bridge. See, lowest bridge ID means how the bridge ID is going to be there. Again, I am repeating. Bridge ID is going to combination of two things. See, priority is same, your MAC address is going to be tiebreaker. If priority is lower, by default, that is going to become my root bridge. So root bridge role, I hope you understand, guys. It's a very important to select the root bridge. Now, how the root bridge election is going to be happen? So the root bridge election is going to happen. The first is lowest priority, then lowest MAC address. It is going to become the root bridge. So root bridge central reference point means every communication, means any topology change is going to be happen. Any notification is going to be happen. Change like TCN is going to be generated. Topology change notifications, any kind of the like MAC table is going to be updated. That all refer to via the bridge ID. Bridge ID is going to be make sure everyone is updated with the latest topology informations. So you can run the STP instance from the every switches by using this bridge ID and root bridge. That is going to be useful for your layer 2 infrastructure. So I hope you guys understand how to select the bridge ID and what is the selection process of the root bridge. Now we have to do the more deep dive. Like you can see, there is a MAC address, MAC address, MAC address, MAC address. If priority is going to be same, means all switch priority is same, then MAC address is going to be only to get in consideration to select the root bridge. But if we have the already lower priority for any switches like 100, it is going to become my root. Now let's talk more about the STP port roles. Means we understand the root bridge. Root bridge is central reference point of the any topology. If root bridge is going to be collapsed, means your entire topology is going to be reconverged and new root bridge is going to be elected. The process is going to be same again, means lowest bridge ID. But there are the multiple port role also available in the STP. And the first port role is going to be known as the designated port. And you also going to find the root port and blocking port. And these ports are very significant roles. So you can see this is the designation port and this is my root port and this is my block port. So who is going to be my designated port? By default, every port which is going downstream to the switch connections. So basically the calculation is going to happen. By default, my root, these two port are going to become DP port. Why? Because they are basically designated port. But why this is the RP? Why this is the RP? I will talk. But why this is a DP? DP is basically think from this point to LAN point of C. If I am going to reach from this way, this is going to again similar cost. If I am going to reach from this way, this is also going to be my similar cost to reach the my root bridge. So in that case, lowest priority is going to be in the situation. Means what is the lowest switch priority? So right now priority is same, then it is going to be MAC address. So might be this switch having a lower MAC address. Right now it's not represented here. That's why it's become the root bridge. In case of the tiebreaker, if you have to select the DP and you have to tiebreaker, then you have to consider the lowest bridge ID. So this switch might be having the lowest bridge ID to reach this destination. That's why it's become the my DP port. And definitely the one port need to be blocked, else it is going to become a loop. So another port is going to be the block port. So this is how it is going to be calculated. So non-root switch having the root port means any ports which just connected in front of the DP, it's going to be RP. This is going to be RP. So RP is means think in this point of view, what is my closest path to reach to switch. So from this port, I can reach from this way also, I can reach from this way also, but this is the very closest. This is going to be longest. So this is never going to become the RP and this is going to be RP and this is known as a forwarding port as well. So I hope you understand a little bit about the designated port. I will do a more deep dive with examples, but the calculation is going to happen. Any port which is connected to the root bridge, that's going to be DP, and all in front of the DP port is going to be RP, or you can think in this way, any closest path from this switch point of view, how to reach the root bridge. This is shortest path and this is the longest path. How this cost is going to be happen, I will show you the cost calculation, how this become the shortest path, how this has become the longest path. There is a proper calculations based on the interface bandwidth. This calculation is going to happen. So I will explain in the upcoming lecture one by one how it is going to happen, but for time being at least you understand. So I will explain what is the root port, how its selection is going to happen in more deep dive in the upcoming lecture, so you guys can understand easily about these all concept. And you can see this is the bandwidth calculation of the ports as well. So earlier I give the just brief introductions. You understand in the high level how this root bridge and MAC address and the designated port and the RP is going to be happen. But now I'm going to talk in very detail. So see in the next lecture about the further discussion. Thank you.